So today we're going to start a new chapter. We're going to be looking at area, and we're going to start with some figures that you're probably pretty familiar with. We're going to be talking about the areas of parallelograms, the areas of triangles, which you probably did these when you were younger, and we're going to add on trapezoids, rhombuses, and kites into the mix of things we're going to find area for. So at this top, on this top section, you can go back and fill these in. These things are listed in the book, but rather than sitting and watching me fill all these in, I'm going to have you go back and fill these things in using your textbook. Okay, so this is on page 79 in your green booklet, and we are going to go through the different area formulas. So down at the bottom, you're going to see the area formulas, and I took this out of the textbook just to kind of summarize all the different formulas we're going to be using in these two sections. So when you have a parallelogram, you're going to be using the formula base times height. One thing you need to remember is that your base and your height will have to be perpendicular to each other. So really, anything can be used as a base that you want. You just have to make sure that the height is perpendicular to the base. And sometimes the height is outside the parallelogram, but that's because it might be leaning in a certain direction. So just look for that height to be perpendicular to the base. The triangle formula is the same idea, but it takes two triangles to make a parallelogram. So basically take the same formula. You're just going to take half of the base times height instead of just being base times height. Again, the height has to be perpendicular to the base, and sometimes the height is located outside the triangle. For trapezoids and rhombuses and kites, the formulas are a little more complicated. Trapezoids formula is area equals 1/2 times the height times the sum of the bases. So just to review with you, the bases are the parallel sides in a trapezoid. So when you go to add the bases, you'll need to add those together separately, and those will be the parallel sides, and then you'll take half of the height times that. And you can do it in whatever order you want, just make sure you're adding the bases up before you multiply everything together. And then finally, rhombuses and kites, or rhombi and kites, that's plural for rhombus, you are going to be doing the formula 1/2 diagonal 1 times diagonal 2. This is a multiplication, not an addition. I get a lot of kids that try to add these. So basically, this is a rhombus up here. If you take one of your diagonals times the other, and you multiply them, and then take half of that product, you'll have the area. And it works the same way with a kite. So if you take one diagonal times the other, and then take half of that product, then you will have the area of a kite. And just to review with you, the diagonals of a kite in both of those are perpendicular, which is kind of why it explains that the formula is going to be the same for both of those. Okay, so let's look at some examples. So we're going to focus just on the area right now, not the perimeter. So when it says find the perimeter, just focus on the area, and we're going to find the area of these different figures. So the first thing I do is, for 1A and 1B, I'm going to do 1A, and you'll go back and do 1B on your own. I notice that is a parallelogram. So I've attached this sheet to your module so that you can print it out or pull it up when you need it. The area of the parallelogram we just talked about is base times height. So what I usually do is I try to write the area formula first, and then I go fill in the information. Okay, so when I look at my parallelogram, since this is sitting horizontally, I can use that as my base. So my base can be 21 as long as I figure out what this height is that is perpendicular to the 21. So to do that, I'm going to use this right triangle right here, and I'm going to be doing Pythagorean theorem to find my height. So 8 squared plus height squared equals 17 squared. And then when you solve this, you're going to get a height of 15. Okay, so now I know my height. Just make sure that the base you're using is perpendicular to the height you're using. So the area is going to be 21 times 15, and I'm going to get 315. And because I'm in area now, and I'm doing a centimeters times a centimeters, it's going to be centimeters squared. So keep in mind your units for area will just be a squared unit. If we were doing perimeter, it would just be centimeters. Okay, you'll go back and try 1B. All right, so now we're going to get a little more complex. We're going to be looking at parallelograms that have special right triangles in them. So you'll do this one, and I'll look at this one. So again, my formula is area equals base times height, and I'm going to use the base of 32, which is also this base, and then my height is going to be perpendicular to my base. So I need to find this height so that I can plug it into the formula. So what I'm going to use is this 30, 60, 90. My short side is 12, so I need my long side over here. So that's going to be 12 radical 3. So now I'm going to plug that into the formula. The base is 32, and the height is 12 radical 3. Okay, when you multiply, we're just going to multiply the numbers out front, and we'll leave the radical as radical 3. So this is called an exact answer, and then we put meters squared because it's area. If you were to multiply that out as a decimal, the approximate answer would be 665.1 meters squared, but most of the time we will leave things in exact form, just like last chapter. All right, so those are your parallelogram examples. Now we're going to move on to our triangle examples. So when you look at your formula for triangle we just talked about is base times height, but then you still have to take half because there are two triangles in a parallelogram. All right, so I usually start by writing my formula down, 1/2 base times height. We're just going to focus on area today and not perimeter. This one, actually, I wrote it in the wrong one because you're going to do 3a, so I'm going to bring this over and do 1/2 base times height here. I'm going to do 3b with you. Okay, so when I do a triangle, again, my base can be anything, but my height has to be perpendicular to my base. So if I want to use the base of 29, then I've got to find this height. So I want to point this out because some kids have trouble with this. Do not use this entire base of 35. This white part out here is not part of the shaded triangle. This is just helping you find the height, but don't include it when you go to do your formula. So the base is just 29. Don't add that extra 6. Okay, we're going to use this right triangle in order to find our height. It is not special like the ones up here, so we're going to have to do Pythagorean theorem again. So we're going to set up, and I'll put it over here, 6 squared, and that's going to be my height squared, equals, and then my hypotenuse is 13 squared. So 6 squared plus height squared equals 13 squared. Okay, when I solve that, I'm going to get a height of 11.5. You are allowed to round these to the nearest tenth so that it's easier to plug into your formula. So now I'm going to do the area as 1/2 of 29 times 11.5. I'm going to type all this into the calculator, and I'm going to get an area of 166.8 centimeters squared again because we took centimeters times centimeters. So when you're doing Pythagorean theorem to get a piece there, if you want to use a decimal for that, that is fine, and then you'll get a decimal answer. All right, so we're going to move down here. You are going to try 4A after the video, and I'm going to do 4B. We're still dealing with a triangle, so we're still going to be using the formula 1/2 base times height. But the difference in this one is we're going to start working backwards. So we're going to be putting in these numbers and trying to find the x. Okay, so in for the area will be 357. Then I'll have the half. The base is 34, and again, the height has to be perpendicular to the base, so x is the height. So this is just a little algebra working backwards. You can either double 357 and then divide by 34, or you can take half of 34, since it's an even number, and get 17, and then go back and divide by 17. So x for this is 21 inches. All right, and then I'm going to do 4C, which is also a backwards question, just a little more intense. This one you're going to draw your own picture. So it says the base of a parallelogram is twice its height. Okay, so I'm going to draw the height here, and it says the base is twice the height. So I'm going to put in the height is x and the base is 2x. And I'm going to come over here, and I'm going to take the area of the parallelogram, which is 72, and find the base and the height. So I write my formula first, base times height. I'm going to put in the 72 for the area. The base was 2x, and the height was x. Okay, so when I multiply this, I get 72 equals 2x squared. Remember, x times x is x squared. Now to solve this, you need to divide by 2 first. So you're going to get x squared equals 36, and then square root both sides. And yes, we normally have a plus or minus 6, but remember that this is not going to work for a height, it's the negative, so you're just going to keep the positive 6 for the height. And then remember the base is twice that, so 2 times 6, the base would be 12. And these would both be in feet because you're measuring the length or the base and the height of the parallelogram. Okay, over here we're going to skip these two just for time's sake. You do not need to go back and do these two. we're going to go down to the bottom and we're going to do some with rhombuses and kites and trapezoids, which are a little harder. Okay, so when we look at 3A, we have to figure out what shape it is, and we can tell that 3A is a rhombus. So we're going to be using this formula right here, 1/2 diagonal 1 times diagonal 2. So I'm going to write that out to the side, 1/2 D1 times D2, not plus. So then I come to my rhombus and I notice that, or I think about the diagonals being bisected. So the entire diagonal here would be 12, so this would be 1/2 of 12, and this entire diagonal would be 14. Now I'm just going to multiply these together, and once I multiply them together, I'm going to get an area of 84 millimeters squared. So remember, it's 1/2 D1 times D2. All right, you're going to go back and do this. This is a kite because it has these sets of equal sides, but you still complete it the same way as your rhombus because a rhombus and kite have the same formula for area. Okay, now we're going to be working backwards a little bit with some rhombuses and kites and trapezoids. Actually, just kites and trapezoids. Okay, so let's look at 4A. This one has an area of 92, and they would like you to find x, which is this diagonal. Okay, so I come over here. This is a kite because it has two pairs of consecutive congruent sides. So I'm going to write down the kite formula, D1 times D2 times half. And then I'm going to go in here, in for area, I'm going to put in my 92 because I already know the area is 92. This diagonal I don't know, so that's going to be x for the whole thing. And then this diagonal is 22 for the whole thing. Now all I have to do is do what I did on the other page and just work backwards. So I can do this a bunch of different ways. I usually take and do half if I have an even number. So that's going to make 11x, and then I would just divide by 11. So this is going to give me x equals 8.4 inches. The other option is you can multiply by 2 and then divide by 22. Okay, this is the first one we've had with the trapezoid, so let me pull out the trapezoid formula. The trapezoid formula is the 1/2 times height times sum of the bases. So I'm going to write that up here. 1/2 times height times base 1 plus base 2. And remember, the bases are the parallels. Okay, so this time it tells me that the trapezoid's area is 177. So in for area, I'm going to put 177. Then half, then my height, and again, my height has to be perpendicular to both bases, so I'm going to use 13. And then I'm going to put in the sum of my bases. Well, I have an 11 plus an x, and it doesn't matter if you do 11 plus x or x plus 11. Now, the only thing we need to do is work backwards to solve for x. This parenthesis will be the last thing that we move. So you can do this a couple ways. What I probably would do is I would probably move my half to the other side since 13 isn't even. I would take 177 and I'm going to times by 2 and I'm going to get 354. So I'm going to times by 2, which is timesing by the reciprocal to move that. And then I have 13 and still 11 plus x. Now I need to move the 13 because remember the last thing I'm going to touch is the parenthesis. So 354 divided by 13 is going to be a decimal. So I'm going to round that to about 27.2 equals, this is gone, so now I have 11 plus x. And then I'm going to subtract 11 and I'm going to get x is about 16.2 centimeters. So that's how you work backwards in the trapezoid formula. Okay, last example, we're going to find the area of this kite. So again, it's a kite because you have two pairs of consecutive congruent sides. All right, so let's look at the kite formula again. The kite formula is the same as the rhombus formula. It's 1/2 diagonal 1 times diagonal 2. Okay, so I'm going to write my formula down. 1/2 D1 times D2. Now I'm going to see if I have my diagonals. Well, this is 6. This is, that's hard to tell, isn't it? So this is 6 here. That's not in a good spot. So that's 6, and then these pieces are both 10, and these pieces are 17. Okay, so to get my diagonals, I'm going to need to be doing some Pythagorean theorem. So keep in mind the diagonals are perpendicular in a kite and a rhombus. So first I'm going to do this little triangle here, and I'm going to do Pythagorean theorem to get this piece. So that's going to be 6 squared plus x squared equals 10 squared. That's, you might recognize that as a 6, 8, 10. x is 8 when you do Pythagorean theorem. So this is 8 and this is 8. So that makes this diagonal 16. So I'm going to go ahead and put 16 in there for the whole diagonal. And then I'm going to also need to be using this diagonal. Well, I know this piece is 6, but I need this piece. So I'm going to have to put an x on that. And I'm going to use Pythagorean theorem one more time. So I'm going to do 8 squared plus x squared equals 17 squared. I'm going to solve that with Pythagorean theorem. I'm going to get x equals 15. Okay, so that means this piece is 15 and this piece is 6. We have to add those together because we need that entire diagonal. So it's 15 plus 6, which is going to be another diagonal of a 21. Okay, now to finish out, we just times these together. So you can take like half of 16 and do 8 times 21 if you want, or just type it all in. You get 168 inches squared for the area of your kite. Make sure that you go back and do these that we have skipped. You'll want that extra practice on there to see if you can get them right, and then check the answers with the key on Canvas. Thanks.